Hey guys, so here's, again, chapter not important. Today we're going to balance equations. So the first thing is, why do we balance equations? Because the number and type of atoms in the reactants must be the same as the number and type of atoms in the products. And so a short way of saying that is we start and end with the same stuff. And why? Because of the law of conservation of mass. Which says atoms cannot be created or destroyed in a chemical reaction. But it's the conservation of mass, right? So this is what we did. This is the very first thing we did in class. We did those 6 labs, and we discovered that mass doesn't change unless something is added or subtracted. Well, in a chemical reaction, everything that's added and subtracted are already written in there. Well, at least the atoms, the rearrangement of the atoms is what is written in there. So that's just repeating the first thing. So what do we do? So all reactions in nature, they occur balanced. All those, even when we added mass, like when we burned the steel wool, nature made that the perfect oxygen-iron ratio. Like it didn't mess with it. So it just happened naturally. But we don't get balanced reactions. Like when they're written, they're not balanced. So we balance it, and we only add coefficients to balance, meaning coefficients are large numbers in front. In front of the formulas. So we'll just do a bunch of examples because that's how we do this. So step 1 is to have a skeleton equation. So there it is. And then really it should say all the skeleton equations are going to be given to you. So we take inventory. So what is that? So I always just write the elements like right underneath the arrow, and just the order of the reactants. Of course she was. Okay, so like you just go straight through. 1 Ag, 1 N, 3 Os. That 3 only goes to the O, not to everything. 1 Cu, that's the reactants. Okay. And then on the products, there's 1 Cu, 1 Cu. The 2 goes to both of these things like before. 2 Ns, 6 Os, and 1 Ag. There's that list, but as we notice, the atoms don't match up. So now we put coefficients in the front to match both sides. And this is the order I do it. I always just start with the first thing that's not right. So the Ags are okay, but the Ns aren't. So the product side has 2 Ns. So that means the reactant side needs a 2. And all you do is put numbers in front. So I put a 2 right there. But the problem is, as soon as you put a number in front, you have to re-inventory that chemical. So what that does is it changes silver to 2, N to 2, and O to 6. And then, so then I always go with, I fix 2 things, like the N's and the O's are okay, but I messed up the Ag. So then I go over and fix that. And 2 Ag, and that's it. Then that changes that to a 2, and now everything matches up. Products and reactants match, and the equation's balanced. Here's another one. I end up taking the reactants and products out. Just the numbers over here are the reactant side, the numbers over here are the product side. If you need to write reactant and product, go for it. But okay, inventory. Look, 2 Als, 3 Os, 1 Cu, 2 Cls. Okay, so I counted those right. Okay, and then the product side, 1 Cu, 1 O, 1 Al, 3 Cs. And again, they don't match up. So again, the first thing that's off is the Al, so I fixed that one. And then re-inventory, 2 Als, 3 Cls. Okay, so again, I fixed one thing, but I messed up the other. So then I go back and fix the thing I messed up. That's just how I do it. So 3 6 CLs. Well, how do I know how to make 6? I put a 3 in front of here. And because it's the front number, it's coefficient times subscripts, if I haven't said that already, which I don't think I have. So now there's 3 CUs and 6 CLs. And again, fixed the CLs but messed up the CUs. So then I go over here and put the 3, and that makes 3 CUs and 3 Os, and now we're balanced. Awesome. Okay, another one. It says try this one on your own, but I'm going to give you my hints before I even click it up. So my hint is, you see how SO4 is in parentheses? Think of that as one thing. So like if I were to do this list, my list would be PB. It would be SO4 because that's one thing. It'd be AL and F. Okay, so numbers. 1 PB, 1 SO4, 1 AL, 3 Fs. 1 PB, 2 Fs, 2 ALs, 3 SO4s. And that makes balancing so much easier. So then look, the SO4s are off. So what do? I go over here and I put a 3. And that makes this 3 and this 3. And I messed up the PB, so I put a 3 over here. And that makes that 3 and that 6. Okay, so fix the PB, like those are okay, but now this is funky. So 6, if I put a 2, isn't that nice? It works its way out. 2, and then 2 times 3 is 6. And, oh well, there's the numbers. And print, easier to read. So there you go. That's the order I would do it in. Okay, this one, my hint is anytime you have a CH plus an O, always, always, always balance them in that order, CH then O. And actually, and I have a hint slide next, but like do C and then H and ignore O till the end. Like don't even count it up. So 1 C, like seriously, 1 C, 4 H's, 2 H's. And balance the C and the H first, and then count the O's. Like, that's what I'm saying. Like, okay, so now look, the H is off, so I'll put a 2 here, and that makes that a 4. And now I'll go through and count my O's, because my C's and my H's are good. So on this side, I have 2 O's, and this side, when you have a plus sign in the middle, you add them up. So there's 2 O's here, plus another 2 here, so that's 4. So that means I have 4 over here, and what do I put over here? A 2, and oh, that works out. Yeah? 4. Oh, so I'm going to erase, and I'll click, and I'll have that. But that's, oops, one of my hints. Alright, so we're going to do the Blotter equation. I realize there's a bajillion, but just because, and because we drew this a bajillion times. So, 2 H's, 2 H's, 2 O's, 2 O's. Like, okay, so 2 O's, or 2 and 1 O, so I put a 2, 4 H's, 2 O's, and I put a 2 here. And so we've done this before. We've drawn 2 things. We did it just with gases. So remember that picture from unit 04, maybe, like right before we got out? 2 H's, 2 H2s, C2 H2s, 2 volumes of H2, 1 volume of O2 makes 2 volumes of H2O. So volume, or just the coefficients, it's like saying 2 boxes. And you can even mark all of this off and just do 1 in each. Oh no, yeah. If you just did 1 compound in each, I'm going to erase this. Like 2 H2s, 1 O, 2 H2s, 1 O2, and makes 2 waters. So, okay. So here's my hints. So hints. Hint number 1. It is okay to change coefficients. If you're going through and you're balancing both sides and something messes up, it's okay. Just change it. If elements are in 2 different places, you add them. That's like this, not that one. This one, you know, we added the O's. We added the O's. Treat polyatomic ions as 1 unit. That was doing the SO4 as 1 thing. Now this one, I'll have one question like this. So it's really long and wordy, but it's one side of an equation has a water, and the other side has an OH plus an H2. Well, you think of water as HOH and treat it like one H and one OH, because your H's and OH's are separate over here. So if you think of this as one H and one OH as two separate things, like that's what you do. So to balance this, okay, so what would my list be? It would be one NA. Okay, so NAs are good. But then I have one H and one OH. Well, over here I have two H's and one OH. So this is one of those, I think, when you balance it, it would be two there, but then I'd have to do two H's and two OH's. And then that's two NAs and two. So the balancing is 2, 2, 2, 1. That's kind of really long and wordy, so good thing we don't have to write that down. Save oxygen for last. It usually works itself out, almost always. And then combustion reactions, that was the CH and O. That was my do C first, then H, and then O. Really, I should say do C and H first, ignore O till the end. Okay, so it says, again, this would have been an old assignment, but I'll put like 5 balancing problems on here and leave room so you can do your list. So good luck, guys.